Rust is an innovative and relatively new language that introduces new approaches to the old problems of programming. I think that Rust is a lot safer and faster than many other languages, which would make it the best language for native OS development nowadays. Its popularity is rising, and we are seeing professional applications written or rewritten in Rust. In this episode, we will set up a Rust development environment for Oatmeal, which is an AI-powered chatbot written in Rust. Oatmeal can use OpenAI, Olama, or other engines, and it works completely in the terminal as a command, although Oatmeal was originally designed to integrate with shell-based editors. And it currently supports integration with NeoVim. We can install Oatmeal as a command, but today we will use it in development mode. First, we will set up the Rust toolchain with Ansible, then clone the Oatmeal repository, build it in VS Code, and run it using the Rust cargo. Installing a development environment for Rust is pretty easy and straightforward. We need to download an installer and run that installer. But before we can do that, there are some dependencies that we need to install. And those dependencies are different between Red Hat systems and Debian systems. So for Debian, we need to install the build essential meta package, which refers to multiple packages that are required for building a development environment on Debian. For Red Hat, we have two development groups, two development package groups, the development tools and the C development tools and libraries. And notice the at here, which refers to a package group, not a single package. So we load the variables first, and then we pass the resulting variable to the package model in Ansible built-in. This will install our packages on both Debian and Fedora, and then we can download the installer from Rust Up. This will be a shell script that we put in temp, and then we run that shell script with -y or -y because we want to accept all defaults. With this, the environment is set up. Now we need to bring our code. So as we did in the previous episodes, we assume that we are working on multiple projects at once. So we loop through cloning the projects, and when the loop includes first cloning the projects and then applying snippets. And snippets are code files that we overlay over the Git repository, and we do not necessarily need to or want to keep in the Git repository. This could be variable files that are like specific to our environment, as we will see in this example here. Or they could be data files or anything that we want to overlay over the code. So by this, we have all our code ready, but let's look now at defaults here. Do we have anything? We don't have any defaults. Let's look at the variable file before we look at the role. For installing Rust, we have the usual suspects here, and notice that if I activate this file, I'll have a Fedora container, and I have tested the role with Fedora and Debian. We need to be generous with resources because Rust development includes building, compiling, and linking OS packages or libraries. And this takes a long time and requires a lot of resources from the system. So we need to be generous with the cores, we need to be generous with the space and with the RAM. Other than that, we have one project, which is Oatmeal. I'm not downloading any other project now. And we have an overlay that we will see later, and we download it from our GitLab instance. This would be the configuration for Oatmeal, and we will see how to install it. Later on, we changed the inventory, we add a file, and we see the role. The role is also very simple. We have the usual suspects for recreating the environment. Enable SSH as we have seen for Fedora. This is the same role that we did before, and we run it only on Fedora. If we have Fedora in the template, then we configure the development environment, and for that we run the base role, then we run the Rust role. We need to run the Rust role in the username, in the active username, not in the root user, because we will be setting up development for the development user. So let's try running this playbook now, and we will see what happens. And I'm running it with the recreate equals true, and I already have an environment that we will be remove. We have removed it, so I will speed up the video and come back when this is done. We have built the environment and it's active now, and if you notice here we have 2.72 gigabyte right now in the environment. But if we start, you will see what happens when we start building Rust. So now I'm opening the development, and you see I have already connected to the development environment from the development container. So I open inside. The first thing we need to do here is we need to install the Rust Analyzer extension. So let's look for Rust. You need to be careful not to install the Rust extension. You need to install the Rust Analyzer extension. That extension will be deprecated. So we installed Rust, and we need to install also the cargo extension, which is Rust Package Manager, the crates extension. Okay. So now we can also install Toml and better Toml if we want, but and we can also install a debugger if we want. So if we look for the LLDB debugger, we can install all these extensions. But while we are installing, notice that the Rust Analyzer is working. And once we open, we have a file open, so let's close this. And we open the main RS file. So now Rust Analyzer is downloading its dependencies, and CodeDB, Code LLDB is downloading dependencies, and Rust Analyzer is also compiling and preparing our source for development. So you see that it is building the models that are required to run Rust. And if we come to the main here, you see that we can run the code from inside the development environment. I'll wait until Rust Analyzer is ready. So as long as it is building, we can start working on it, but we need to build it in the shell as well. So here I can do cargo run, for example. Let's run it first with the config create. While this is running, I can explain the config file. So in the config file, we are using Olama as a backend for Oatmeal, and we are using the Chinese model because I want to show you some interesting results with the Chinese model. And I am connecting it to my Olama server, which is on a laptop that I need to start. So it will start while we are working. And that's it basically. I'm disconnecting it from the editor because I don't have NeoVim here, and I don't have a clipboard in my terminal. So basically the config file is created, the build was successful, and the config file was created. So what I can do now is I can copy this file to this location, and I can copy on Linux here. I need to use cp, not copy. So the config file is copied to the location now, and if I expand this and I run cargo run, before we do that, let's look at this warning here. You see this warning here on line 70. So if I control click here, it takes me to the line. And we see in line 70 that we are defining a muting variable, a mutable variable that has a default value. And then we are overriding this default value here and here and here. So the compiler is warning us that you are assigning a value here that you are overriding for all the operating systems, Mac OS, Windows, and Linux. So why are you doing that? Maybe there is a mistake here. And if I remove the default value, the error disappears. You see, no problems here. If I return the default value, I still get a warning. No warning. Warning 1. I remove it, I have a warnings. The warnings are 0. But I still agree with the developer that in all variables it is safe to, and it is required to assign a default value. This comes from C style development. Probably in other languages you don't do that, but I still agree with the developer that we accept the warning and we leave the default value. So now if I want to run the Oatmeal, if I want to run the application in development, we will see what we will get. Building, we have this same warning. Hi there. And you see we are connected to a chatbot. It is connected now, and we are talking to Quimby, to Quen 14B. I wanted to show you how I tested the censorship in AI models. So let's ask it, tell me a Chinese joke about the Chinese government. Let's see what Quen will answer us. As an AI developed by Alibaba Cloud, I'm committed to providing responsible content. Therefore, I cannot provide a joke that directly targets or makes light of the Chinese government. Instead, it gives me another Chinese joke. So this is an example of censorship in these types of models. And if I want to ask it, tell me a Swedish joke about the king of Sweden. Here it does not have any problem with telling you a joke about the king of Sweden. But about the Chinese government, no, it is responsible and it cannot tell you a joke like that. And it's only about the Chinese government, not that the joke is in Swedish. So I will speed it up. Let me break it and ask it to tell me a French joke about the president of... Bien sûr, now it turned to French. Unplug. It turned to French, and it is telling me a joke about France, but about the Chinese government, no, it is responsible. It cannot provide any jokes about the Chinese government. So this is an example of the censorship we face with these models, and that's why sometimes you need multiple models to get the answers to your questions. Like here I'm asking about a joke, and that's not what Oatmeal is designed for. Oatmeal is designed to integrate with editors, so we could probably integrate it with VS Code or Codium if we write an integration for that. And Oatmeal also can connect to Olama and other chat engines. You can connect it to OpenAI, and there is a pull request for Oatmeal to connect it to GitHub. I prefer to test it using my own AI server, my Olama server, because I prefer to do all my AI requests locally. I don't like going online to do AI requests. Another interesting thing in Oatmeal is that it's like any chat, any traditional chat application. It accepts commands with that start with slash, and if you type /h, you get the commands that you can support. And with slash model, you can change the model, and you can put a model that accepts instruct. For example, if I ask for my model list, I see that I have multiple models that accept instruct, and those you can ask them about code. So you can give them a code block and ask them to refactor it or to comment on it or to find the errors, find the bugs in instruct models. So now we know that our development environment is working and we can run Rust applications in development. And but I want to show you an interesting thing. Remember that we had only 2 point something gigabyte. Now we are on 6.49 gigabyte of storage. The reason for that is the building the extension, building all the dependencies, and that takes time and that takes memory. So while we were building, we had like very high CPU usage, very high memory usage, and we used a lot of the storage. Now, if we clean our installation, we will get more storage if we need it. But now for a Rust environment, I think a minimum of 8 GB is required. Oatmeal is a fantastic software project, and if you are learning Rust or if you want to contribute to projects, I advise you and I recommend that you look at Oatmeal. It is still a new project, and there is place for so many improvements to be added. So if you are considering contributing to a Rust project, Oatmeal can be a very good candidate that might live long in the future. I have other updates because Dashi released a new version, and that version includes our pull request that we created in a previous video in this series, I think in episode 8. And that is fantastic news. Apparently, Dashi is still under development, and that makes me very happy and proud because I really like that software. In our series, we will do dynamic DNS, and we will connect Kia and Bind, the two services that we added to our router. Then we will keep building the router while we are doing development environments. So if you have a suggestion for a development environment, please send me that in the comments. After that, we will do WireGuard with Ansible, and as I said, that's WireGuard as you have never seen it before. I would like to thank the people who follow me on YouTube, GitHub, Medium, and the other platforms, especially the people who leave me comments. Those interactions with the audience give me the feeling that my work has value to some other people, which drives me to go forward in my channel. If you feel that my work provides any value to you or my code is useful to you, please let me know in the best way possible for you. As usual, the code will be in my GitHub repository, and the link will always be in the article and below the video. There will be an open pull request for the code that I am writing in this video, and this pull request is will stay open until the next pull request is published. Then I will merge the code for this pull request. We built previously a development environment for Dashi that is based on Node.js. We built a development environment for Drupal and Laravel Lumen and WordPress that is based on Apache Linux or Apache or Nginx, and PHP and MariaDB. I welcome comments on the code and comments on the videos and comments on the articles. I also welcome code reviews or any type of feedback on GitHub or all the other platforms that I contribute. Please feel free to fork my repository and to modify it to match your Devlab. If you are interested in AI, please watch my AI videos. And if you like me to do more developer-oriented or family-oriented AI videos, please let me know in the comments. I appreciate your feedback, and please follow me and let's talk in the next episode.